And our next speaker is Simon. Simon is one of the developers behind the Flutter study group on Slack. Also, he's a Flutter developer, Go and Android developer as well. And he's one of the organizers behind the Flutter Hackathon 2020, where I also took part in. Unfortunately, I didn't win.
That's
and
right.
If you are a Flutter developer, definitely follow him on Twitter because he has so much cool content there. So, hi, Simon.
Hey, how are you today? I'll say first. Yeah, I'm hot. That's what it is today. Hot.
Yeah.
Definitely. Yeah, I can't wait to get out of this heat at the moment. It's too hot for me.
Yeah, here's the hot as well. Okay, Simon is gonna talk about the navigation of Flutter. Okay, the stage is yours.
Thank you. So I'm gonna have to forgive me. I'm leaving the windows open, the fans on. It's way too hot to not have that on at the moment. So, welcome to my talk, Declarative Navigation. We are going to, if my clicker works, talk about a GPS system. Only joking. We're not talking about the GPS system. We're talking about the Navigator to Pager and Router API. Thank you for the lovely introduction. So I just put a bit on here, Flutter Community Lead. I've been helping out with the Flutter community for some time. We also have several community efforts. So I'd like just to bring everyone's attention to that. So there's a Flutter community Medium and a Flutter community GitHub organization where we manage packages and so on. So we're always looking for people to help in terms of managing those packages. So we have some templates on there. Please put your name forward. Happy to review anyone's requests. I've been a CTO of a company I started up with a friend of mine, DevAngels London. We just basically make apps. So a little free advertisement there for everyone. And you can go follow me on Twitter at DevAngels London. It did start off as a business account. Now it's my personal account. So you may get some jokes and all sorts of things. And I've personally been doing programming for 20 years. 11 of that is definitely Android, and a good couple of years now in Flutter. So what happened since my last talk on navigation? So I did a talk in January at Flutter Europe. Thank you for all the organizers of Flutter Europe. That was brilliant. To my chagrin, I did this whole bit about initial route and how it was, how you can do things with it. You can go watch the video. Anyway, it's been removed from the API now. So if you've had any problems trying to use that, that is why. It's been removed to support the new Pages API, which we're going to be talking about. And yeah, I don't think I've got any better preparing for talks. So you have to forgive the slides. They will be available after the talk, these new slides. And I've already got a repository up and working that you guys can download and start looking at, as I'll show you in a minute. And we can work through some examples together. If you want to look at the last video and slides, which don't cover what I'm covering today, that covers specifically routes, transitions, the navigation stack, and various other things. You can go, you will be able to get these slides afterwards and click on that link there for the video and the slides for the last talk. Navigator 2.0. The question is, why do we need another API? And what's wrong with the current one? Well, I mean, the good answer to this is just, if you've ever experienced any problems with the current Navigator API stack that doesn't do what you want, well, then, there's a good reason right there to replace it with something new. If it's not doing what we need, let's make something better. But, all jokes aside, I mean, it's been around since the very beginning. It doesn't really follow the usual sort of declarative paradigms that we now come accustomed to with widgets and so on. So, and the other problem with the current Navigator version 1 is that it's very opinionated in terms of it limits our access. Like you can't see the history stack, you can't do a lot of things. So with the new Navigator API tries to sort of address these concerns. Yeah, and I think also the key point here to take away from this is also definitely look into the Pages API, and soon the new Router API once it leaves master, so that you can sort of get prepared, because the Flutter team is working on state restoration, and that is all part and parcel of navigation, so that if your app is completely terminated, so they put it in the background, let's say on Android, put it in the background, the system cleans up the processes and shuts down the application. Well, we want it to save the current navigation stack, and then when the app comes back alive again, we want to restore the navigation stack. So it's very important for us to sort of link the Navigator 2.0 stuff with the state restoration. So the new API is broken into 2 bits, and we'll be talking about the Pages API. I've just named it a declarative approach because it really is. So we'll go through some key concepts. So first of all, I would like to say it is stable. It's currently on the stable branch. So if you're using 1.20, you can start using this immediately today, which is all the more better because I'm telling you right now, like, brilliant. It's absolutely brilliant. Once you get your head around the initial things, which I'm hoping my talk will help you with, that it will just sort of release you from the complications that the original Navigator sort of gives us. It is to be said that it is an addition to the current Navigator widget, right? So the Pages API changes the way that the Navigator stack works. The Navigator widget takes a new constructor, which is a list of pages. So you think of it just like a stack, right? That takes a list of widgets as children. It now takes a list of pages to be displayed. So a page, which is the new class, you can go find this in the current API documentation, is like a widget. It just provides the configuration for the resulting route. So we'll go into that in a second. So as I said, it acts like a widget. So a page has a contain update method, which compares its runtime type and key. This is very important because that's the distinction that we make when we're dealing with the widget tree. That when you see them, you say, oh, if it has the same runtime type and key, then it's going to remain on the screen. So this takes us down that declarative approach to UI to the pages that we display in terms of if they match, it doesn't have to make any changes. It doesn't pop or push anything from our navigation stack. And a page instance, an instance of a page class, its only job is to store the configuration for the current route when and create the current route when requested. So it very much, think of it very much like the stateful widget, which has a create state method, so that when it needs to create that widget, it calls create state, that then initializes everything. So a page is like that. There's a create route where you can initialize that route, provide parameters, and do anything custom that you feel that you need to. And that create route method is actually called by the Navigator itself. The Navigator, sorry. So Pages API example. So I just want to provide this. So this is like your ABC simple example of a page. So we have a type parameter. The T here is the return type of the route. So I didn't pass that across to material page route here. That's just inferred. But the key concept here is page extends route settings. So wherever you use route settings before, you can use the page class. And as you can see here on line 13, we actually pass this as the settings for the route that's returned. So that like makes a hard linkage between the route and the page that created it. And as you can see here, we're just storing in this case, we're storing a method that builds the widget, the route. A builder that returns the widgets for the route. And then we pass the naming key across. So here's a good example of it in action. So if our initial route is, let's say, /category5/item/15, on the previous navigation system, if you set that initial route, it would try and create a route for category, a route for 5, a route for item, and a route for 15. And you had no real recourse to kind of override it. And if you did your working around the API, it's not very nice. So with the new approach, we get to create a navigator with a set of pages, and we can decide what those pages are. And in this case, I've created 3 pages. We have a home screen, which is the default /route. Then we have category 5. So those 2 parts of the route are joined together to show a category screen of ID 5. And the same goes for item 15. So in this case, that's an item screen with ID of 15. So something you can see now, do not forget to add the keys. So it's very important. So just like the widget tree, as I said earlier, the way it does the comparisons, it compares the runtime type. In this case, that's my page. They're all the same. So if we didn't have a key in there, if we removed one of those pages, it would not know that the stack had changed, right? And we wouldn't see the transition of your pages. So it's very important to have keys on your pages, okay? And in this case, I use the key factory method to create a value key of string that's just unique enough for this purpose. Okay. So in this situation, I've just commented out that last one, item 15. And in this situation, the navigator would see that page is now 2. That item 15 that was there before has now, the item 15, my page at the bottom there, has now been removed. So then it will do the pop animation for us. And we'll pop the route and do the normal thing that we normally expect, which is the way the route pops and notifies and everything else. So, and it animates that. The key thing that we can now do, because we have control of this history, because we have control of the stack, we can do something like this, where we actually comment out somewhere, in this case I'm commenting out, but remove from our list a widget, let's say for category in this instance, and it would remove that screen that's behind the current one without any animation taking place, right? Now you could do this with the old one, but you'd have to keep a reference to the route. You can do remove route. It is very complicated, and it definitely wasn't designed for that approach. And of course, in this example here, if we were to press the back button, then item 15 at the bottom is popped, and we return back to the home screen because we've now got rid of category 5, right? So, but I think the question here is what happens when we take this to the next step, which is when the navigator pops, how do we remove this the entry for item 15? So that's where this is a new constructor for Navigator, and again, this is in stable branch right now, and we don't really care about any of these details for the old stuff, so we'll just comment those out there. So the key concepts here, we've got pages, which is our page array, and we have on pop page, and this is how if we want to implement the pages array, we need to implement on pop page, right? This is basically how the navigator reports back to us that a route has been popped from the stack. And then we can use that to update our list of pages, remove it, and rebuild the navigator widget itself. If we didn't do that, then the next time the widget gets rebuilt, it would see that there's a new item called a new page in the bottom, and it would animate it in again. So you would get this back and forth happening, which obviously is not what you want. So you need to implement on pop page and remove the page that it gives you the route for. And I'll explain how we do that in a minute with some examples. So there is, you might draw your eye right now because everyone likes transitions. There's transition delegate on line 10 and 11, which implements a default. This is not what you think. It's nothing to do with animation. Not directly. So this is used by the navigator to determine what changes in the pages array indicates a push or a pop or an add or a remove. So like I showed you earlier with the set of pages, if we were to insert pages in the middle, right, not at the top, we're not pushing it on top, we put them somewhere in the middle as we change the stack. So you can imagine we could change the entire history stack underneath the current one, or just change them with the current one, they would all change on the screen. But if we change the ones behind, that's an add operation. They're getting added, but they're not being pushed. A push means that they're getting added and again animated. So push and pop are specifically animations. Add and remove are without animations. It's the key concept. But the states that routes go through, there's a huge state diagram somewhere in the documentation which covers a lot of this. But yeah, just keep those concepts in mind. So I just want to get sort of just talk through these points. This is actually, I think, pretty much verbatim from the documentation. The default transition delegate follows these rules. Firstly, all the entered routes are placed on top of the exiting routes if they are at the same location, so same location in the pages array. Secondly, at the topmost route will always transition with an animation transition, obviously because it's the current one that's on the screen. All other routes below either will be completed or added or removed without transition. And the real point of them providing this to us is so that, again, we can customize this behavior, right? So they parameterized it. We can do whatever we want. If we want to create an app that's completely backwards in its navigation or does something crazy or somehow interacts with web views in some fancy way to do back navigation in the web view, we could do all that with this, and there's all sorts of fun things we can do. And finally, reports route update to engine. This is about how it fires stuff back. That itself is not important if you're using the router API, okay? That's only if you just want to use the pages API without the router API. And finally, at the bottom there, I just put the type def in for the pop callback. So you can see we get the route that's being popped, and we get the result of that route. And what we actually want to do is call route did pop the result to tell the route that it's been popped now. We'll get more into that in a minute. And just a remark here, as you see, the constructor has both. So you can actually mix and match the old imperative and the new declarative approaches. So your first thought, maybe that's a bit right? However, it does help for a steady migration if you want to migrate parts of your app and still keep some of the old behavior. But importantly, it allows us to keep things like dialogues and pop-up routes. So the way it works is you have your set of pages, and then you have we'll get to that in a second. So for example, if you were to specify initial route here, the imperative API would call onGenerate initial routes, create those routes, and push them on the stack inside the Navigator, on top of those that are generated by the pages. So the pages like your sort of your underlying set of screens, and then anything else is done on top of that. So you can imagine that we show a dialogue, well, that's put on top of the current set of pages in front of the user. Same goes for like a pop-up list or anything like that. These routes are just put on top. So we kind of get to take advantage of both imperative and declarative approaches. Those routes that are not part of the pages list are called pageless routes now. That's the name given to them. Any route that is not backed by a page is a pageless route. Okay, so I know there's a lot to take in, and we're going to go through some examples later, but we're just going to talk briefly about the router API. So I originally wasn't going to do the route. I wasn't going to talk about the router API because it was still being worked on. 4 days ago, it was committed to the master branch. So I raced to get some semblance of information to you, and we're actually going to try some live examples of this today. So I have to say, this is what I've always wanted from the Navigator. So let's see, what is it? So the new route API solves the new requirements that we just saw to rebuild the Navigator. It has to be said though that you don't have to use Navigator anymore. So you can provide your own overlay, whatever set of widgets you want to display your set of pages to the user or based on routes. That's all up to you now. You can do whatever you want. So we have the freedom that we've always wanted, right? The route API is split into a few key concepts, and we're going to go through each of them. So route information provider. So this is the link between. So first of all, so let me be clear. You have the router API and there's a router widget. So the router widget wraps a Navigator widget, right? So it has a build method that returns Navigator or any other widget you want. But that router widget requires a few parameters to get started. So in this situation, we want the route information provider. And what that does is that interacts with the operating system to let us know, well, first of all, so we can let the operating system know the current route. So if we navigate inside the application, so the user presses a button, we can tell the operating system, hey, we're now on this new page, change the URL. And that's in fact what happens on Flutter Web. So that the URL provided from this goes and changes the URL in the address bar using the HTML5 history API, state API, whatever it's called. However, you do not have to be concerned with this. So the platform provides the framework provides a default implementation called Platform Route Information Provider. And the key behind this, though, is that you just don't have to deal with it, right? So it's only if you want to do some very custom behavior, but again, they're bringing the customizability, they're bringing that stuff to us that we've always wanted, yeah? So again, there might be lots of concepts here, but once you understand the new concepts, how they interact, there's hardly any code to actually implement in them. Another point to mention here is the router widget can be nested. So like nested navigators, again, we don't have to use Navigator, but you can have nested routers and they can interact. Again, you would have a provider on your nested one that provides, obviously not the system level route, but the sub route, right? That's how you can sort of provide a nested routing behavior. So in that situation, you want to make sure that if you're using a nested one, then you want to provide null. This parameter is null. Right. Anyway, and just a key point that default one works the same way that we've experienced in the Navigator 1 API, and that is it uses widgets binding observer to observe the current widgets binding. That's one of the base classes of Flutter to monitor the did push, did pop state of the UI, so that we can know when the operating system wants to push or pop a route. So you press the back button, for instance. Moving on. So then we have route information parser. So route information parser. Now, again, all these new classes. I know it's a lot, but we're going to go through them in a minute. You'll see them in code. So don't worry too much. Route information parser. It takes what we previously called the route name. They now call this route information because it can provide more stuff than just the name. But think of it as the route name. So we're taking like this string of whatever we got as our initial route, and we convert that into an internal custom model of our choosing. So we can have any object we like, right? That represents those parameters and parameterizes those things. So think it as like the current state of the route. So we're going to get back to the route. The route delegate's got quite a few callbacks and the way it behaves, and we'll look at that in the code. But this is where the magic happens. So, like a custom painter or one of the other things, you provided custom multi-channel layout, whatever. You provide a delegate, which provides the callbacks and functionality that the router needs to perform its base set of logic. So the reason why the original Navigator 2.0 ticket has been closed, right? And that's been closed because they've provided all the necessary functionality to use the new Navigator API now in master branch. However, what we're missing right now, and they've opened up a new ticket linked to the old one, is some default implementations, or default's the wrong word, some interesting implementations of the route delegate. So I encourage you all, once this talk is over, go experiment, see what you can play around with, because they want your feedback, right? The Flutter team want the feedback from the community to know what they should be building and what helping us build great apps, right? So have a look, have an experiment, make your remarks, use the ticket. I'll put the ticket ID up on the screen at the end. And finally, it has a back button dispatcher. So I haven't played around with this yet. The back button dispatcher allows you to nest them. So it essentially takes the place of will pop scope using routers. So this allows us to kind of nest that back button and have nested routers all with nice back button behavior linked together. So this is the state diagram, I guess. I've forgotten the name for these things. Hang on. That's about flowchart. I know, whatever. Anyway, so as you can see here, when we get the initial route or new intents or new routes getting passed through, they go through the route name provider, which creates that custom model, which converts essentially links the external operating system to our parser. The parser then receives that string, the route name string, and converts into a custom model. And then that gets passed to the route delegate with either set initial route or set new route callbacks. The set initial route callback is obviously used when we have the initial route being passed in, so we can perform whatever logic we want. Fire off a task to go check to see if there's new notifications, who knows what. And and obviously set new route, overriding that. And again, the back button is pressed. We go through the back button, dispatch a chain, and then that goes to popping a route again through the router delegate. Now, the key point here again, so it's declarative, right? So you have to stop thinking about that kind of imperative approach of like, I'm going to push and pop stuff, right? That the idea is you change your app state, right? So you can imagine that you change a variable, and that means, oh, the user is now logged out. So now your new set of pages is the logged out view, instead of the logged in view. So your pages list can almost represent your app state, right? So that's what this kind of notion of what the router delegate does. It modifies it based on the app state. It changes a set of pages that are going to be sent over to the navigator, right? And once those changes are made, it then does a rebuild. The router widget rebuilds and calls the build function of our delegate and obtains the latest set of pages and the navigator widget. So an example of that actually in use is right here. So the user taps a button. The tap handler modifies the state, so that can go off to our app state and, I don't know, remove something or anything you like, Boolean. You can have your own stack of pages, which I'll show you in a minute, or you can do whatever you want. Again, customizability being the key. Then that then notifies the router that those things have changed using it's a standard change notifier interface. So just do notify listeners. That then tells it to rebuild the UI, rebuild the navigator with a new set of pages, and then the pages are going to change, right? The router's going to change. So that's kind of like the flow. It's a very similar flow that we see with all of that. Anything else that you've done in Flutter where you might press a button and something occurs. This also gives us, I think probably many of us, I know I have in the past, have sort of come up with those problems where you want to push or pop a page. And because it's a command that you issue during a point in time, it says you can't do this right now because you're in the middle of doing a rebuild or some other change. And of course, that kind of creates a circuit dependency in that one build depends on another build, that depends on another build. So you do like a schedule micro task or add post-state callback or something like that to say, make the navigation change after the current build is finished. So what we're actually doing here is because we're modifying the app state, that build process becomes part of that flow of changing widgets now. So you don't get that kind of out of order execution. So this is what you see on the right-hand side is the new Material App Router constructor. I mean, Material App itself has lots of parameters, so we're gonna let's comment out the ones that we don't care about right now. And as you can see, we're left with the same 4 that the router widget uses. So provider, parser, delegate, and dispatcher. And there they are there. Again, so these are just passed on to the router. And then the router is used in place of a navigator widget inside the Material App. So where Material App, actually underlying Material App is widgets app, but basically instead of using a navigator, it now uses a router. And it's up to you to provide a navigator widget configured however you want inside of your router delegate. So I know there's a lot of information to sort of cram into like half an hour. So what we're going to do now, we're going to sort of drop away from this, hopefully. And if anyone wants the current code that we're going to be looking at, I will drop this, I guess, in the live chat somewhere, I guess. There you go. I don't know if that gets posted. I'm sure someone can post it. Yeah. I'm sure one of our admins can post it in the chat, so you guys can check it out if you want. This is literally the code that we're going to be looking at right now, and we're going to start running it. So I've put myself in presentation mode here, so this is going to take us a second to kind of work through. I do not want to run the router. Well, I see what I'll do. I'll walk you through the pages example first, right? Hopefully that's big enough for everyone. So as you can see here, this is pretty much what you saw on the slides, right? So we have a set of pages right here. And then the key point here is I'm just using this is, again, a quick example. I would not recommend you build it this way, but I'm using instead of a home widget, I'm using a will pop scope, and inside that I'm calling the maybe pop on my navigator. I'm providing my own navigator with my set of pages and my on pop page function. And as you can see here, this is essentially my state is a set of pages. That is my stack. And then we remove, when you do pop, we take the route name, the route settings, which is the page, remember, and we remove that from our set of pages, and then we tell the route they did pop, right? So this again satisfies that first point, that we need to make sure that the page set is updated when the route's popped. Again, the key point here is that the way that you do this is completely up to you. So the framework is giving you the freedom and not giving the specifics, and that's why it's very important that the next step in Navigator 2 is to provide some default is the wrong word, but some go-to use cases, common use cases that we all want from the new API, right? Again, maybe something like this, where we could like parcel this up into a common use case. And there's our my page from the example that we gave earlier, followed by some simple home page, category page, and item page with some colors. So item page is blue, category page is green, and home screen is red. So if we run this, just run the wrong one again because I'm super clever. Yeah, I should have gone through that whilst I was talking about it. Okay, so we wait for Gradle now, and hopefully the streaming is not going to slow Gradle down too much. Hope everyone's enjoying themselves and finding what I'm talking about interesting. All right, so here we go. So, yay, we have our item 15, which again, if you notice, like when we start our app up, that's it. We're not providing an initial route. It's just a set of pages. So that's our declared state. We've decided that this is our initial state that we want to start the app up. A good example, reason why this is very important, is things like when you're dealing with push notifications, right? You deal with a push, and maybe a push implicitly changes the state of our pages, or maybe you tap on a notification outside the app, and when you launch, you want it to display a certain page within the app. These kind of things become really easy to do. So let's well, we're running this now. So if I hit the back button and everything goes right, there we go. So what just happened is it ran, it wanted to pop the route. So Navigator saw that we were using the Pages API and on pop page, called our function. We then remove it from our set of pages. That then pops the route, which starts the animation process and does lots of other things. And because we've removed this and we called set state, now we're left with these two pages alone, right, in this array. So then when the widget gets rebuilt again, it will build, and lo and behold, pages will only have those two items in it. Yeah, and again, I can hit back again, and we're back to the home screen. Simple enough. We'll take questions on this, so please, pardon me, feel free to pick my brains on this afterwards. I think the more interesting one is the router stuff, which I really wanted to show you guys. So we're going to dig in deep. I'm thinking that given the amount of time that we have, I would like to maybe see if we can rustle together a quick example. I don't know, maybe using maybe a quick example of a store or something where we can have some like detail pages, some item pages, and handle the route changes that way. But the example's here, so we're going to run that example and we're going to give it a go. So again, let's run our router example while that's building in Gradle. While it's building on Gradle, we're going to say, I'll talk you through this. So first of all, oh wow, that's great. Right, we'll come back to the example in a second. Yeah, we'll come back to the example in a second. So you can see here we're using material app router, and now the only two parameters I'm providing are a parser and a delegate, right? The reason why I'm passing the delegate as a variable is because my delegate actually holds my state for my stack, which we'll get to in a second. And what I've decided to do, just for a laugh, and this again is about if you wanted to migrate and transition, I've provided an on-generate route, which is the sort of the old way through my route delegate to build the routes for the screen. Why not? We can remove this in a second, and we can push it as a separate commit or something, and we can see how it looks. So, and as you can see here, the very, very basic example of a parser is really simple. So in this case, my custom model, because I'm really, really complicated about this, is just a string, right? As a good example, it's a string, but the key, again, I can't say this enough, the key concept here is that you can provide any model you like. So, you know, if you take that initial route information, by the way, route information is getting prepared to have not just the path, the initial path, which is what they call location now, but also state. And you can read about this, I'm sure, soon. But this allows us to provide that state of like scroll positions and various other things for our current sort of page route. So again, if the user comes back and they were previously filling out a form, we'll have those form fields all there, that when we restore our navigation stack, we can have all the fields filled in still. I've lost where I was in my code. Lucky me. Alt-1, that's a good tip. Right. So in this situation, okay, again, they use a future, which is quite nice, which means you can do some states, some asynchronous things, maybe look at an API or some other various thing you want. In this case, obviously, the most optimal, fastest solution is to use a synchronous future. So we use a synchronous future, and we just return the location. So I'm just taking the route name and saying that is my that is the state, that is all the state information I need to bring back my state, my route. I'm using it's an example, right? I wouldn't recommend that, but you know, this is a good example. And then again, restore. So when we want to come back, it can say just create new route information with a location, which is for my custom. This is my custom configuration. Remember, this is not just the platforms only giving us a string because that's why I said I need, right? So that's restoring a route information from my string. So here's the delegate. So delegates, they can get quite complicated. And I do want to just point out, this is the way you want to construct your delegate at the top here. So it's whatever class your delegate is, extends router delegate of your custom model. And then if you want to use the Navigator's POP interface, then you want to add POP Navigator router delegate mix in those string. It's a mouthful. And then interesting enough, we do another mix in. So we're essentially doing a diamond here, a diamond class, and we're mixing in a change notifier. That's because router delegate, which we're going to look into right now, extends listenable. So the change notifier provider gives us that. As you can, I'll walk you through this interface here, and then we'll see how we've implemented it. So first of all, we have set initial route, which by default just calls set new route path, because most of the time the one and paths are the same. The point of having this method in here, though, is so that you can override that behavior, right? And which I can show you what we can do in a minute. And then we've got pop route. Again, when the backbug dispatcher tells us that we need to pop the current route at the top, then that's the function that needs to perform the edits and the changes to do that. Get the current information. That tells us to return back our current model for the current state. And finally, we have a build function, which returns, in this case, we're going to return a navigator. And again, it recommends us here to use that mixing that I was telling you about. I mean, you know, there's what, 4 or 5 functions. It's not overly complicated. I think it's just that kind of expectation, maybe. So what we've got here is our stack, our marvelous, really complicated, highly functional stack of strings. I'll explain why we have this static of method in a minute. We'll get there. So we have a stack of string. That's going to be our stack of pages, essentially. Our stack of remember, string here is our model, which is data only, right? So this is just our visualization of what the stack is. This is our model. Again, we can provide that. That could be a set of pages. We could also do have multiple model types for that all. And I have one base type that declare that the parameters for different pages. We can really customize it. It's very important you understand it. Anyway, so when you use the pop navigator router and delegate mixin, we have to have a navigator key. So this override here is for that navigator key. This allows us obviously to control the stack of the navigator, the history stack. Current configuration, simple implementation. If our stack is not empty, then return back the last one that's on top. That gets us the current one that we're seeing in front of the user. Otherwise, there's nothing in the stack, so we return null. If we want to get to the stack outside of our router delegate, it's very important that we make that unmodifiable, because if that stack is modified, we need to rebuild our router will need to rebuild its children, in this case, a navigator. So we don't want that stack to be altered outside of this class. So that's encapsulation. So in this case, I provided my own. So just like the original navigator, I provided my own two sets of functions, my two functions here, which is push with a new route and just adds it to the end of the stack and notifies that it needs to be rebuilt and rebuild all those pages. And again, the same thing goes for remove. We're just saying remove and then notify that we need to change. There's our initial router. Initial route configuration. We'll have a play around with that in a minute. New route path again. Remember, this is not us pushing or popping or manipulating our stack, because that's up to us now, right? We're not using the navigator to do that, although you still can. This is more about that the operating system has detected that there's a new route. So if you just want to clear the entire stack and rebuild the entire set of things from our configuration. Remember, I'm using a string, but that can be whatever you want. So in this case, we just clear and add that to the stack, single entry point, and we just do a synchronous void. And this is just so that we, again, if we want to make this asynchronous, we can. And then our on pop page, which again is from the navigator, and this basically tells us, this basically says, is our stack not empty? Is the last one on the stack the current one we're trying to pop? If it is, remove it from the stack and notify the listeners. We could just say, from my use case here, I'm thinking that you always want the latest one if you're going to do pop, and if the navigator pops something that is a pageless route, then obviously it's not going to match. So, but anyway, and then we've got a little print statement here for debugging, which we'll get to in a minute, so you can see what's actually happening. In this case, it says gives our delegate, and then the stack follows. In fact, you know what? I'm going to say just do that. Maybe. Just for funsies. There we go. My router delegate. The ID .stack is a slash right now, so we have our opening slash route. Again, we're providing our navigator. So when build is called, we're providing our navigate widget again. Any widgets we like, we could wrap this. We could put some nice fancy thing. I mean, here again, let me be clear. We could now wrap the navigator with a stack to provide like a pop-down notification when a push message comes in. So we get a push message come in. We update our router. Our router goes, okay, I need to rebuild. Does notify listeners, and now we can display a pop-up notification above our navigator, and will persist even if you change the pages that's behind. Again, you can see here, for example, we just go around, we just loop over our stack and add my page, which we showed earlier with key name. Sorry, this is a new my page. Be clear about this. Interesting enough, I passed across this route factory because I just wanted to make it sort of backwards compatible and show you how you might migrate. In this case, I'm passing over a route factory, which is our on-generate route. And as you can see, here is an implementation of a page, which essentially just has a a route factory. So there's not anything to this, right? It doesn't do anything with widgets or anything like that. However, obviously, as I said before, this is just very generic. We can actually have pages as our state. We could push a page with a hard-coded widget in there for whatever screen we want. There's lots of variations that we can do here. And then what we see below is the default homepage widget that you can see here, the scaffold. That's the starting thing. And all I've done is I've made the counter static. So when we press the plus button, we have multiple routes. The counter increments over those routes. And then I've just created 3 callbacks for the 3 action buttons you see below. So we have show dialog, and this is just to show that you can just use the standard Navigator behaviors and things that we'd used before. We can use the Navigator just like we would do before. Like we can just do show dialog and it will work, even though we're using the Pages API and so on. Remove last, which is our little delete trash can here. Now this is the key. So anywhere in my hierarchy now, below obviously the route, the material app, in this case the router, I can now do material route delegate of, because this is that static function I made earlier. Here it is, and that does router.of and gets my delegate back. Obviously, I can go ahead and use the parser to dispatch any of the parameters. In this case, I'm going to call the delegate. And where was I? Scroll back down. Oops. In this case, I get the stack and say, well, if the stack is greater than 2, then I'm going to remove the one behind the current one. So I'm going to remove the last, but I can't remember the name of that is, but yeah, the one before the last one. And then again, increment sets that counter, great. And then each time we increment, we're going to push a new route name. In this case, instead of doing like /ABC, I'm literally just doing route and a counter. Again, the names themselves don't have any. We don't have that kind of mapping of name to page, although we can, right? To be clear. So what you see here, again, is the standard thing: scaffold with a name with a counter, and there's our 3 buttons. There's nothing to it. That's the entire example. So let's give it a go. So first of all, let's hit plus. And I'm going to see if I can make this bigger than the bottom here for you. So as you can see, it's added route 1, and we've got the back icon at the top, just like we did before, right? And to be clear, that's done push. Let's run this push method here. Push is added to our custom stack array and called notify listeners. That tells the router to rebuild the widget, and we'll come down to here, return a new navigator with a set of pages now with our new page being represented. Yeah. So again, I can hit plus, and there's page 2 and page 3, and you can see there's our route, there's our initial page, route 1, route 2, route 3. Now I hit delete. Nothing changed on the screen. We're still on route 3. However, what we've done is we've removed route 2 from our history stack, something that would have been very difficult to do with the previous API. If I press delete again, oh, wrong button. I'll press delete over here. And then you can see now we've got / and route 3. So if I hit back, I'm going straight back to my root route. I haven't had to go through those intermediate steps because I can now make the choice to if I push these again. So in this case, now I've got 6 and 7. If I press the delete button, I'm getting rid of 6. And if I hit back from 7, I'm back to 5. Right? You can make the changes to the navigation stack however you want, right? So there are very complex behaviors that you get with certain apps, and this is why this is very powerful. It really takes Flutter to the next level. And again, as I showed, you can press this bar, which shows a dialog, and that dialog, if you notice, has not updated our stack, right? We haven't got print, it hasn't rebuilt the navigator. This is just portrayed on top of the current set of pages. Now, if we wanted to, we could add another page. It would be added behind this. It would be added behind this, but on top of the other page, right? Anyway, so where do we want to go from here? First of all, I guess, what's our time? Do we want to answer some questions, or do we want to Let's have a look. Let's have a look.
Actually, we can go for the questions because we have like a ton of them.
Oh, sure. We can go for some questions.
Okay. The first question is: I need to get a GPS position every 10 minutes on my app, even if it's closed. Can I do this with Flutter, or do I need some integration with Kotlin?
Well, I was hoping for actual route navigation questions, but we'll go with normal navigation since I made the joke. No, you're not going to do that. So it used to be possible, but in the new versions of Android and so on, they restrict background access to GPS positioning. You can do it with, if on Android, I can tell you can do it with, you have the you install yourself as an admin app, which has higher permissions. But again, the user needs to provide the extra set of security roles and so on. Yeah.
Okay. And what is the difference between page and route?
Okay. So the difference between page and route. So a route is actually what you it holds the state of where it is in terms of transition and other things. It binds everything together. So a route is what manages the state of what you see on the screen. Whereas page is, I guess, well, but the best way of saying it is route is the mutable state. That's the current set of variables that declare what's going to happen on the screen. Whereas page is immutable. It's this is how I want to create a route. So it's the initial set configuration for a route. Hopefully that helps.
Yeah, okay. And what is the use of the key property? Is it important?
The key property, do we have any context on that at all?
No, we don't.
Okay, so I'm going to assume, well, we'll talk about the two ones I've shown. So one is on the page. The key property is there for, I think I did speak about this a little bit, I'll go over it again. That's there so that we can differentiate. So the navigator can tell two different pages apart. The key makes it unique. So like a key in real life is quite unique. The key in the app is unique. So based on this runtime type and key is now unique. And this is how Flutter sees widgets in the widget tree as being unique. And we use the same concept in the new Navigator 2 API. And then the other use of key was on the navigator itself. And that's so that we can do things like pop the current state and manage the navigator stack itself.
Okay. And what is the difference between navigator.push or just using the name route?
What is the difference between and using named routes? So I just want to be clear about so something that people I don't think understand. So a named route simply goes through. So the way named routes work in Navigator 1 is you pass a name, and it puts that name through a table and gets a route back out. Right? That's all it does. So named route, every route has a name, but the way you push it or the way you start it depends on if you want to go through that initial table that you provide with Material app. You get to do that with the new Navigator. I haven't shown it here. However, you can just create your table, and inside your push function or whatever function you want to manage your own stack, you can simply look through that table. Is the route name in that table? Then pass that builder over to your page, and that's it. You've now done exactly what the current framework does. It's that simple.
Okay. Next question is: Can we show built-in material dialogues in declarative way to have them in pages stack?
Oh, sure. So something that I think again a lot of people misunderstand. So when you maybe I can find in my example here. Can we switch back to the screen? So if I can find the function. So I just want you to point this out. So here we go, show dialog. alert dialog right here is the widget that displays. So this here is literally the widget that displays on the screen. So if I was to copy this, right, and then create a let's say, what would we say, route, let's say route 3. So we can say if we push, we'll just hack this in right now as a good example. It's a terrible example, but we'll just hack it in and say if name is equal to route 3, yeah, then return my page else one, and key, and have the same key. Name will have the same name, and then the interesting point here is our route factory, just so I can reuse the same page because I'm being lazy right now. This can return a material page route, and that has a builder. Return our alert dialog, right? And if we wanted to be very clever, we should probably center that, I guess. I don't know. So if I restart the app now, so there's route 0, route 1, route 2, and there's me being silly. Hang on, I know what it is. Yeah, that should fix that. Hang on, let's start again. Again, Tyrant 1, live coding 3. There you go. So this has pushed it on the stack, you see. So we have got the dialog, and if you hit yes, it's all failed. This is what happens when you live code. Oh, that's because I didn't call this context. And again, so another little thing, which I could do actually, if I made this a page route builder, should think opaque, yeah, opaque false, color black 54 or something. The builder is a page builder, is it? I can't remember. Page builder, yeah. With slightly different parameters, so we'll just do this. Okay, so fingers crossed, and everyone's happy. Do 1, 2, 3. There you go. So as you can see, what we've essentially done here, I've hacked this in, and I'll commit this code so you've got it. I would not recommend you just chuck this straight in your build function for sure. Like you would want to build your page route and have a nice proper sort of dialog page configuration, right, which does a lot of this for you. But as you can see, we just push the dialog as a page, and I can hit yes, and it'll pop it. So we're still using the page stack. You can see here, look, there's route 3. It got popped back to route 2, right? So yeah, it's perfectly viable to do that. In fact, if we hit yes, we can actually do something funky like this and say push route 4, or I don't know, route magic. Just give it a different name, right? Just to show you what actually happens here. So we start again. 1, 2, 3. Hit yes. There's the next page called route magic that's now pushed. And if I hit delete, that's going to delete the dialog. I think we just saw a bug there, which is interesting. Anyway, and route 4, route 5, and hit back, and that'll go back and not show the dialog because the dialog's now gone. There's a little glint there of a little frame of the dialog, which might be actually a bug, or it might be my implementation because I'm just doing it really quickly. But anyway, that shall answer the question. Right. Sorry, what was the other question?
Yeah, perfect. That was absolutely cool. I guess we have time for the last question, and it's for how long can we have stack restoration? Is it stored somewhere?
So here's the key concept, right? That you can, so whenever that stack changes, you can store it out. So I'm going to give a plug. I made a package called state_persistence. You can go find it on pub.dev. And that literally does what you expect. So by default, it's got a default implementation of the JSON file, and you can give it any set of widgets, any set of variables you want. It will store them in the JSON file and return them back to you. So you can use that in conjunction with this to store your configuration for your set of pages. Again, in this case, I've just made a string array, but that could easily be I could easily store that to a JSON file, and when I get it back, I then create my new set of pages from that. So yeah, it's definitely possible, but how long? As long as you have your app, right? I mean, yeah, we'll see. Thank you, Philip. I see these comments. Yeah, thank you.
Yeah, Simon, thank you for an amazing session. The live coding was absolutely amazing.
You're welcome.
Thank you for joining us.